Alright, inverse tangent of x is very similar to inverse sine of x. Y equals inverse tangent of x means that x is equal to the tangent of y. Now our x, what can we take the inverse tangent of? We can take the inverse tangent of anything. All real numbers. Alright, because tangent goes from negative infinity to positive infinity. Now, what kind of answers can we get out when we take the inverse tangent? Here's why it's very similar to inverse sine. The answers that we get out when we work out inverse tangent have to be between negative pi over 2 and pi over 2. Notice that I didn't put an equal to bar under the inequality signs. That's because you can't take the tangent of pi over 2 or the tangent of negative pi over 2. That's where we have our vertical asymptotes. That's where tangent is undefined. So that's the big difference between inverse sine and inverse tangent. You can't have one of the endpoints as your answer. But as far as where it's defined between negative pi over 2 and pi over 2, it's the same. You can also use the shortcut to find angles in the fourth quadrant if you know the angle in the first quadrant because of the even-odd property for tangent. The tangent of negative theta is equal to the negative tangent of theta. So if we know that tangent is a positive, say a positive pi over 4 in the first quadrant, if we want that angle measure in the fourth quadrant, its multiple, just make the angle measure negative, so it would be negative pi over 4. So here's how we could use that. Let's say that I wanted to find the inverse tangent of 1. Well, since I'm taking the inverse tangent of a positive, then I'm looking for the answer where the tangent would be positive, which is the first quadrant. So I have to say to myself, the tangent of what in the first quadrant equals equals 1. I need to say the tangent of what in the first quadrant equals 1. And that's going to be pi over 4. The tangent of pi over 4 is equal to a positive 1. So if I wanted to find the inverse tangent of, say, negative 1, then I want the answer in the second quadrant. I'm sorry, not the second quadrant. I want the answer in the fourth quadrant because I'm taking the inverse of a negative. So to get that, the shortcut way is to say, okay, the tangent of what is positive 1? Well, I just worked that out, pi over 4. To put that in the fourth quadrant, just put a negative in front of the angle measure. So the inverse tangent of negative 1 is equal to negative pi over 4. Alright, what about the inverse tangent of negative square root of 3? So what you need to say to yourself is, okay, first, the tangent of what is a positive square root of 3 in the first quadrant? So the tangent of what is a positive square root of 3? If you think about tangent as sine over cosine, then the sine of pi over 6 is 1/2. The cosine of pi over 6 is square root of 3 over 2. If you divide those, you get square root of 3 over 2. Or I'm sorry, square root of 3 over 3. And that's not what we want. So if it's not pi over 6, what's the next logical choice? Pi over 3. The sine of pi over 3 is square root of 3 over 2. The cosine of pi over 3 is 1/2. Square root of 3 over 2 divided by 1/2 gives you square root of 3. So I did all of that to remind you that the tangent of pi over 3 is equal to a positive square root of 3 over 2. So if I want the answer in the fourth quadrant, instead of pi over 3, I use negative pi over 3. The inverse functions, the tangent of the inverse tangent of x is also equal to x, just like the inverse sine worked out. And the inverse tangent of the tangent of x is also equal to x. The only difference is, if the inverse is on the inside, remember x can be anything. So x is between negative infinity and positive infinity. If the inverse is on the outside, then the x needs to be between negative pi over 2 and pi over 2. And so if you need to understand how to work out this, know that it works the same as inverse sine, so you can go back and watch the inverse sine video.